Good morning, children. Welcome to our chemistry online class. In last class, we discussed about the formal charge and how to draw the Lewis structure, and we discussed about octet rule also. But if we check octet rule, what was that octet rule? How can we define octet rule? Based on octet rule, in order to attain stability, the valence electron should contain 8 electrons. So for attain stability, what atoms or elements will undergo? They will either transfer their electrons or share their electrons. This is what octet rule. But if you check the elements, some elements are not following these properties. Some elements having some variations from octet rule. So there are some exceptions case. So in today's class we are going to learn about the limitations of octet rule. Okay, so let's start. Let's see what are the limitations of octet rule. So there are mainly three types of exceptional cases. That is, first one is electron deficient molecule. Second one is molecule with an odd number of electrons. Third one is molecules with expanded valence shell. Let's see one by one. We check the first case, the incomplete octet of the central atom. That is, if we check the compound beryllium chloride BeCl2, here you can see one beryllium. It is shared electrons by two chlorine atom. If we check and if we count the electrons in beryllium, that is the central, beryllium is the central atom. So if we count the number of electrons, we can see that 1, 2, 3, 4. It is not following the octet. Even though it is not following octet, it is stable. The compound is highly stable. So in octet rule, we stated that in order to attain stability, atom should contain 8 electrons in the valence shell. But if we check beryllium, it is not contain 8 electrons, but it is highly stable. So in some compounds, the number of electrons surrounding the central atom is less than 8. For example, lithium chloride, beryllium hydroxide, beryllium hydride, BCl3, boron trichloride. So many examples are there. So it is the first case. Second case is odd electron molecule. For example, if you check NO, NO2, if you check here, if you check the number of electrons in nitrogen, that is 1, 2, 3. There are only 3 nitrogen, 3 electrons in nitrogen, even though it is highly stable. But in the case of oxygen, 1, 2, 3, 4, 5, 6, 7, 8. But it's containing odd number of electrons. So in molecules with an odd number of electrons like nitric oxide, nitrous oxide and nitrogen dioxide, the octet rule is not satisfied for all atoms. But in the case of oxygen, it is satisfying the octet. But in the case of nitrogen, it is carrying 3, that is odd number of electrons. Hence, it is not following the octet. It is the another example, another exceptional case. And the third case is the expanded octet. Expanded octet means octet is 8 more than octet. And if we check the third period element after silicon, non-metals are not following the octet. They have the ability to expand their octet, that is more than 8 electrons. The reason is after, if we check the periodic table, after silicon, we can see that apart from 3s and 3p orbital, there is 3d orbital also available. So in third period only the 3d shell will come. In first shell there is 1s only. In second shell there is 2s and 2p. So from the third period there is starting of the 3d period. That is our transition metal will start. So what will happen is, so the 3d shell also available for bonding. So it is the reason for the expanded octet. So in a number of compounds of these elements, there are more than 8 valence electrons around the central atom. This is termed as expanded octet. If you check the compounds, for example, PFY, SF6, H2SO4, you can see here. Here, if you check the phosphorus, it have the ability to attach with the 5 fluorine atom. So if it should attach with 5 fluorine atom, each fluorine will donate 1 electron and and the phosphorus will donate 1 electron. So each bond is representing 2 electrons. So if we count 2, 4, 6, 8, 10, it's contain 10 electrons around phosphorus. In the case of sulfur, you can see it's also sharing 12 electrons. 12 electrons there are 12 electrons around the sulfur atom. In the case of H2SO4, we can see 12 electrons around the sulfur atom. So it is why, because there are the ability of the 3D series, 3D orbiter. So it will also participate in the valential electron transfer, electron combination. So apart from 3s and 3p, 3d also will participate in the combining like sharing of electrons or transfer of electrons, etc. So this is known as expanded octet. And another limitation is octet rule is based on chemical inertness of noble gases. We know in octet rule it is stated that our noble gas is having high stability because they have 8 electrons in the valence shell. They have complete octet. Hence, they will not undergo making chemical bond with any other element. This is there is one of the postulate of octet rule. But if you check some noble gases, they will make compounds with fluorine, oxygen, etc. Here you can see the example XeF2. Xenon is reacted with fluorine, will give xenon fluoride, krypton fluoride, xenon oxyfluoride. You can see this noble gases also will form compounds. It is also one of the exceptional case, but in octet rule it is stated that noble gases will not undergo any reaction. Hence, it is having octet in its valence. So it is also one of the exceptional case, and this theory does not account for the shape of the molecules. This theory could not explain about the shape of the molecule. It could explain only the sharing of electron and transfer of electron and the octet, but it could not explain anything about the shape of the molecule. And it does not explain the relative stability of the molecule, being totally silent about the energy of a molecule. It could not explain about the stability of the molecule. These are the major limitations of octet rule, and in next class we'll move to the next model. If one model is failed or one rule is failed to explain certain phenomena, we'll move to the next model. So after one class we can discuss that. So in next class we are going to deal about bond parameters. Then we'll discuss about a new theory called valence bond theory. So I hope all of you understood what is the limitations of octet rule. Okay, thank you.